Hey everyone, today we're going to solve two equations using logarithms. So for the first one, on the left hand side, we have both terms being log base 2, so we can combine those using the product law, and that's going to look like, excuse me, the log base 2 of x minus 4 times x plus 2, like so, and that's equal to 4, right? Now we can pop the base on over to the other side using the laws of logarithms that we know well. So the 2 makes its way on over, and this log becomes an exponential on the other side. And so now our equation reads, let's use blue. Our equation is going to read x minus 4 times x plus 2 is equal to 2 to the power of 4. Right? That means in the next step, let's expand through the left-hand side, right? It's in factored form on the left-hand side, but it's not equal to 0, right? And so that's not as much use to us yet. So let's expand this left-hand side. That's going to become x squared minus 4x plus 2x means in total minus 2x minus 8 is equal to 2 to the power of 4, i.e. 16. Now let's bring the 16 on over to set the quadratic equation equal to 0. And so now we're going to have x squared minus 2x minus 24 is equal to 0. And now that we have it equal to 0, we can go ahead and factor and solve, right? And so we have x minus 6, x plus 4 equals 0, i.e. our solutions are x is equal to 6 or x is equal to negative 4, but we should be mindful of any and all restrictions, right? Our restrictions are any values of x that would make either the base, that's not going to be a problem, or the arguments non-positive. And so that means that we need x minus 4 to be bigger than 0, and we need x plus 2 to be bigger than 0, right? We need the arguments to be positive. And so what does that mean? That means that x needs to be bigger than 4. This one means that x needs to be bigger than negative 2. This one is less restrictive than this one. And so this is the restriction that we're really going to have to hold to. And so looking at our two possible solutions, which one of those satisfies our restrictions? Well, only this one. And so x is equal to negative 4 is what we call an extraneous solution. And we don't actually consider it. And so x is equal to positive 6 is our unique solution. Okay. Number 2, I like this one. We have the log base 2 of x squared minus 2x all to the power of 7, right? And it's equal to 21. This might look a bit tricky at first, but what we can use the log law, the power law, to bring the exponent from the argument up front. And now we have 7 times the log base 2 of x squared minus 2x equals 21, right? And now hopefully this looks a bit more solvable. We can go ahead and divide both sides by 7. Let's try to be consistent with the colors in the holiday spirit. Let's divide both sides by 7. So this cancels out. And so now we have the log base 2 of x squared minus 2x is equal to 21 over 7 is 3. And now we can go with a similar process as we did above, right? Using one of our laws of logarithms, we're really raising both sides to the power of 2. But in any case, no, that's not what we're doing. How do we do this? We're taking the log base 2 of both sides. Yes, we're taking the log base 2 of both sides, rather, pardon me. And what that does is the same thing it did in the example above. It makes the base switch to become the base on the other side, the base of an exponential on the other side. And so now we have x squared minus 2x is equal to 2 to the power of 3, right? And now again, we want our quadratics to be equal to 0. And so we have x squared minus 2x. 2 cubed is 8. Let's subtract that from both sides. So minus 8 equals 0. Now we can factor and solve. And so we get x minus 4 times times x plus 2 is equal to 0, meaning that our possible solutions are x is equal to positive 4 or x is equal to negative 2. But again, we should be mindful of restrictions. Our restrictions are that, again, the argument needs to be positive, right? And so for us, that means that x squared minus 2x needs to be positive, right? Now, if you imagine what x squared minus 2x looks like, well, that's x times x minus 1. And so when is that function greater than 0, i.e. above the x-axis, right? Well, it's going to have roots at 0 and 1. So it's going to have roots at 0 and at 1. It's a positive concaving quadratic, right? An opening up quadratic, a smiley parabola, if you will. So it's going to look something like, and it has a y-intercept of 0, of course. And so it's going to look something like this, right? As smiley parabolas with roots at 0 and 1 do. And so when is that positive? Well, it's positive outside of the two roots, right? When x is either less than 0 or greater than positive 1. And so those are our restrictions for x. X can either be less than 0 or x can be greater than positive 1. And if we look at our possible solutions, x equal 4 does satisfy these restrictions, and x equal negative 2 also does the trick. And so in this case, we get 2 possible solutions. And we're done. So I hope this helps. I hope you're starting to put together all these laws and logarithms to solve these equations. And thanks for watching.